And I'm Jessica Bunting. I don't think I introduced myself. I am often helping provide support for these webinars that we do. Today, I'm here based on my involvement with the campaign to prevent falls in construction, the safety stand down, and the new ANSI National Work at Heights Task Force. Did I get ANSI Z359 Work at Heights Task Force? So I just want to go over a few things. I don't want to take up too much time from our pros here, but I did just want to go over before I introduce them that if you don't know by now, May 3rd through 7th is the National Safety Stand Down to Prevent Falls. We're in the 8th year of that annual event that's organized by CPWR, OSHA, and NIOSH. And, you know, unfortunately, based on recent data in 2019, we saw an increase in falls overall, and particularly in construction. You can see our CPWR data center does a lot of research and number crunching on fatalities and non-fatal injuries as well. And if you look here, they've highlighted the focus 4, the top 4 hazards in construction. And so we see that between 2018 and 2019, falls to a lower level, resulting in fatalities actually went up from 321 to 401 just in construction alone. And, you know, fatalities overall went up, but if you look again at the chart on the right, falls to a lower level really contributed majoritively to that rise in overall fatalities. You can see that it went up almost 6%, but all of the other struck by electrocution, caught in or in between, all sort of stayed the same or even dropped. So, you know, that's a really unfortunate thing to see, but that's, you know, why we're here, trying to learn more about how to prevent these and, you know, increase awareness in the industry. So with that, I just wanted to mention that, again, May 3rd, first week in May, is the National Safety Stand Down. We have tons and tons of resources from CPWR, OSHA, and NIOSH, and they are all collected at stopconstructionfalls.com. So I just wanted to put that out there. We also have free hard hat stickers and hazard alert cards that you can order at that site, stopconstructionfalls.com. And I think so. Unfortunately, to get them by the stand down week guaranteed, we have already passed the deadline, but the stickers are great to hand out even after the event, just to recognize worker participation in the stand down. Okay, and you know, with that as a plug, I'm gonna go ahead and hand it over to our panelists. We got a ton of great questions in during registration, so thank you everyone for submitting those. And just again, want to mention, and I will drop it in the chat after I'm done talking, that this is a follow-up webinar. There was one that we did last year, Q&A part 1, and it was, you know, really great information. So I encourage you, if you have not already, to go ahead and watch that in addition to this. And so I'd just like to thank Tom, Adam, Corey, and Dan so much for joining us again and for lending your time to answer a lot of these great questions. I'm gonna hand it over now, Tom, to you so that you can go through a few slides first. You it should say on your screen that you're the presenter. Okay. Thank you.
Yeah, thank you very much. Thank you, Jessica, for that introduction. And thank you, everyone, for joining us. We always know that there's so many different things you can be doing with your day, and we appreciate the, you know, 200 plus attendees joining us to talk fall protection today. It's an item that I think you'll understand, the panelists, how passionate we are about this topic. And so in addition to myself, I'm currently the chair of the ANSI Z359 Standard. We have Dan Henn from Reliance Industries that is the vice chair of the Z359 full committee. Dan also chairs 2 of our standards when it comes to self-retracting devices and horizontal lifelines, and so it's great to have him. Dan's also a manufacturer of fall protection equipment, so he can provide a lot of good details relative to the intricacies of the product that many of you will never see unless you really open up the product in that manner. We also have two folks from the construction industry. We have Corey Gay from Wagman. Corey is a recent member of the ANSI Z359 committee, but he's been attending for several years and has been advocating for the user point of view for all that time. But then we also have Adam Rubin from Zachary Group that is joining us. Adam is the vice chair for the Z359.14 standard. Adam's also very, very active coming out from the worker standpoint, and Adam's going to have quite a bit of just explanation as far as what he can share. Corey and Adam both as far as their journey when it comes to fall protection and how we go through that. So as we go through, we have a lot of questions and so forth, but if there's questions that come in and are chatted in, I'll try to take a look at those and try to weave those in if possible. But we can definitely follow up on those if we have any items to clarify as we go through the material. I'm going to just share a couple of slides as an introductory standpoint and to make sure that everyone understands some background related to the Z359 standards. And one thing I want to clarify is just even though we're all members and very active members of the Z359 committee, we're not speaking on behalf of the Z359 committee, but if anybody wants to attend our meetings, we can pass along information for that meeting. And if you ever need to get some sort of a letter of interpretation, we'd love to help clarify anything related to our standards. But when it comes to our standards activities, this chart really tells it all. This is the item that we're focused on because as we create the standards, we could create all the different requirements, all the different, different drop tests or functional design requirements that comes for equipment. But if the number of fatalities isn't going down, we just really need to challenge ourselves as far as what else do we need to be doing to drive these numbers down. And the thing that we look at, we always look at these fall fatalities, but I know that Dan, a couple years ago when in our Z359 meetings, Dan really brought up that, even though this is something that gets the news headlines as the fall fatalities, is that there's about 50,000 injuries with days away from work behind these. That's really the greater set of these items, and there's a lot of random events that might lead to a fatality, but we need to recognize that we need to be driving down the injuries with days away from work to really focus on this number in a bit more detail. Relative to Z359, OSHA is the law, but ANSI is a general consensus or voluntary consensus standard. ANSI is constantly updating our standards much more frequently than OSHA does. When you look at the regulations for the general industry side, there's about 40 years between the initial regulation that was part of the initial offspring of OSHA, and then it wasn't updated until 2017. From a construction side, the first regulation, or the first significant regulation, modern regulation, happened in 1995. It is still in the process of waiting for an update, so it's been over 20 plus years. But ANSI standards get updated at least every 5 years, if not every 10 years. And so I just wanted to share a couple standards on the screen that are new and available, and highlighting the one from 2020, Z359, which is the Fall Protection Code, and the American Society of Safety Professionals makes that available as a free download. So what it does is it gives you a nice gateway and understanding of the entire Fall Protection Code, because it's no longer just the one Z359.1 standard, but an entire Fall Protection Code that breaks down all the individual components and ways that you can design systems and your program to make sure that you're working on the processes to protect the workers at height. So when you combine the statistics and you combine our standards, really what our job is for the Z359 committee is creating standards that reduce not only the number, but also the severity of the fall incidents, because we are making safer equipment, but again, we need to help organizations evolve their processes so we drive down the number of fall incidents also. So one final item that I want to finish up with here is that in collaboration with CPWR, the Z359 National Work at Heights Task Force has created a fall experience survey, and hats go off to Jessica and her team there at CPWR for creating this survey. And it's something that what we're looking to do is if you have a knowledge of a fall incident or you have an experience with a fall incident, we want you to log that information in. Because unfortunately, there's some gaps between what we can get from the Bureau of Labor Statistics and actionable information that we can implement from a Z359 standpoint. So the goal is really to improve the understanding of the underlying causes in order to inform the standards, create more relevant resources, improve all the outreach, improve future research, but good data leads to good decision, and I think we're challenged right now making sure we have great data, and so that's part of the goals with the survey. So please use the link there. There's I know CPWR just had it translated into Spanish, so we have more options for this fall experience survey. So I would encourage everyone to go to that link, and if you have some information on more than one cases, fill out the links more than one time. So we'd love to get the information that we can start looking at and seeing how we can look at it. So some of the initial information, again, this is preliminary results, but I think what we're starting to look at is what's the biggest contributor to all falls, and what's the primary contributors to the specific fall that the person was giving feedback on. So we're going to get a lot of great numbers here that the folks at CPWR can do their work in analyzing the data so that we can, again, create better interventions, not only for this ANSI Z359 fall protection code, but for the entire industry, so we can better protect our workers at height. Now, you might be looking at some of these items, and you might look at down there and you see, down there at the bottom, I think it says indifference of workers. And when we were creating the survey, some folks really pushed back at some of those responses because it gets into the topic of, quote, blaming the worker. And the reason why we left that response in there was that we wanted to try to use this survey also as a tool to understand, is that a serious issue out there that we need to be aware of? Because, in the end, yes, the worker makes the last mistake possibly that leads to the fall, but what else could we have done in the chain using the Swiss G analogy in order to prevent that exposure from even happening or prevent the incident from even happening? And I know that, Corey, with your work with ACIG, you're pretty staunch when it comes to not blaming the worker. Do you have something you want to share before we get kicked off in the questions about the thoughts about blaming the worker?
Thanks, Tom. Absolutely. So, that's usually, like you said, the last link that could possibly fail is at the point of application with the worker that's using the equipment. And you hit the nail on the head. I think we really need to take a look further back and take a look at planning, take a look at what other options may have been available using our hierarchy of controls. Can we engineer out the hazard? Can we guard the hazard using guardrails? Can we use a different system? And then if we are going to use personal fall arrest or restraint, make sure that we're selecting proper devices and really critical training. And with that training, try to make sure that it is as simple and user-friendly as possible so that everybody is understanding exactly what is required, how to use the different products in the different applications. So, with that, I'll kick it back over to you. But yeah, the last thing that we want to do is look to the worker and say, yes, that person made a mistake. As you said earlier, Tom, usually at that point, it's too late. The mistake's already happened.
Great. Thanks, Corey, for jumping in on that and clarifying that. Let's go ahead and get to the question. So all the panelists were willing to put their contact information here. If you want to shoot them an email from a follow-up standpoint, clarify something that they wanted to share or that they're sharing, please feel free to write these down and follow up. And so I already talked with Corey real quick, and last time, Dan, I think you got the first question. So this first question that we have that came in, we're going to go with Adam on this one. So Adam, playing off what Corey talked about from a hierarchy of control standpoint, we definitely want to focus on the engineering controls, but because they're a lot more effective. But when I look at all the questions we got in, we get a lot of questions when it comes to equipment, because I think there's a lot of situations where clarifying the use and the limitations of the equipment, that's the biggest challenge. So this first question mentions that they heard that Z359 is moving away from the leading edge lanyard language, and they had leading edge lanyard in quotations there. So how can I ensure that the lanyard, the SRL, will function as intended along or near a sharp edge or material type items? And Adam, as the vice chair of the Z359 standard, and with your role with Zachary, obviously, you deal a lot with that. So can you give some explanations, then maybe an example as far as how you effectively implement that from Zachary's standpoint, Adam?
Sure. Thanks, Tom. So I think that, you know, going back to the hierarchy of controls, we really have to, I mean, the best way to make sure that the device performs is not allowing it to touch those edges and the material. And so I think the way you do that is as a first option, I would look at a fall restraint option, and not allowing the employee to get to the edge. If that wasn't feasible based on the scope, then I would say you need to elevate your anchorage as high above your dorsal D-ring as humanly possible, and that way, if you do experience a fall, you won't ever the device will never come in contact with the edge. And I think you know, kind of touching on the leading edge lanyard in quotations there, and that's you know the reason why I think it's smart to get rid of that language is that's really you know, kind of the back brace for lifting, if you will, right? Like it makes you feel like Superman because you're connected with a leading edge piece of equipment when in fact it may not perform in the way you need it to. So elevate your anchorage, try the fall you know, the limiting factor of keeping them as far away from the edge as possible with a fall restraint method.
Yeah, I just want to amplify that Adam, relative to, you know, what Adam shared, is that if you are having to use fall arrest, elevating that anchorage really improves all the measurable outcomes when it comes to the fall protection system: self-rescue, impact forces, clearances, compatibility, in addition to obviously the edge contact, all become much more effective when we elevate that anchorage. So I appreciate you ending with that portion. So Dan, I'm going to kind of go in a similar direction to you. So discuss the forces exerted from a fall related to using a non-energy absorbing self-retracting device anchored at your feet. What is the fall distance? And then also, what is the fall distance for leading edge SRLs anchored at the feet? So a couple different options. You know, one is definitely a misuse, using a non-leading edge rated device. What's the implications associated with that? And then if they are using a leading edge devices, can you share a little bit that, including talking about the clearances? Dan?
Thanks, Tom. And that's a great question, because not all self-retracting devices or SRLs are created the same. And so those that are designed kind of in the traditional sense for use on an overhead anchorage may not have some of the things that are required to deal with the fall arrest energy we're going to see, you know, in a foot level tie-off or a leading edge exposure. And it's kind of similar to equating an SRL to a pickup truck. I remember as a man, my father rented a tent trailer to go on vacation with some extended family of ours and attempted to pull this thing up into the Sierra Nevadas with a 1974 Ford Courier. It didn't work out very well. And that pickup truck just didn't have what was required to pull that load. The same thing is true with a lot of these self-retracting devices. If it's not designed to deal with the specific application or hazards, then our outcomes are going to be pretty poor. So we look at that foot level tie-off or that leading edge exposure, we're looking at an extreme of free fall. And if we stop to visualize what that's going to look like, if I'm attached to the deck or the walking working surface, I have to fall such a distance that the housing of the SRL, wherein the locking device or locking mechanism is contained, must fall past the edge of the walking working surface and invert such that we're now pulling the line out to create our locking engagement. So that fall distance from standing to engagement could be anywhere between 5 and perhaps as much as 8 feet. Now we have our engagement and activation, and then we factor in our deceleration, the expansion of the energy absorber or the rotation of the rotary brake, which is going to be several more feet and is not actually limited by the ANSI Z359 standard. And then we have to account for the height of the worker and, you know, some factor or margin of safety. So if we look at the instructions for most leading edge SRLs in the marketplace, most of them require 16 to 20 feet of clearance below the walking working surface in ideal condition. So an important aspect of using devices in that manner is understanding how much room we have beneath the walking working surface or our fall hazard, and recognizing whether or not there's some obstruction or potential for contact in the next lower level. And as a rule of thumb, if you don't have somewhere in the vicinity of 20 feet beneath you, you're probably not going to have a very good outcome.
Great point, Dan. One item I just want to clarify because it's often an item that people confuse out there in the field. So if I have a device, you know, SRL LE as they're called now, but it's also a Class A or a Class B device, if I'm using it in a leading edge fall, is that fall clearance going to be, you know, the 54 inches per the Class B or the 24 inches per the Class A, or is it going to be significantly more than that?
Oh, way more than that. And it's because those Class A and B designations, with the way the standard is written today, are predicated on the outcome of a fall with an overhead anchorage. So if we use that device in anything other than an overhead application, we're going to see a substantially larger arrest distance. And additionally, and I think it was covered in your question, we're also going to see an increase in the fall arrest forces. And in many cases, if we don't have sufficient energy management systems in place, we could exceed the force reserve or the strength of the device. And as a result, we could see a separation of the line from the device for a catastrophic failure.
Great, thanks, Dan. Corey, I want to go into you with a follow-up comment, and I know you have an end user comment that you want to add to it. But if we're using leading edge devices, can we use those in an overhead application? Is it permissible to use those in an overhead application? And kind of thinking about it in the context that I know when you were on your journey, there's been times where you've looked at your equipment inventory, your fall protection equipment inventory, and said, this is not the right equipment for my end users, and you've had to go through and kind of look at it and really vet the equipment that your folks were purchasing, and almost more importantly, who in your organization was purchasing it. Can you comment a little bit on that, Corey?
Absolutely, Tom. And so we started looking at this maybe 3 to 4 years ago, and you know, we started our journey really taking a deep dive, looking at our fall exposures, where people were working, you know, was there going to be edge contact, what were the general clearances involved, where were the anchor points, all those different things that we look at. We initially thought, there was a group of us looking at it, including one of our structural engineers. We thought, wow, with all the different products on the market today, there just has to be a silver bullet, right? There has to be something that we can utilize that's going to just solve the world's problems, all of our problems when it comes to fall arrest. You know, and when we took that deeper dive and we really looked at the different products, what we had in inventory versus what was on the market, looked at testing, looked at data. We actually went and visited some places and we were able to see some drop tests live. We came back and we said, wow, we really need to overhaul our program. So we did that. And what we did was basically look specifically with the work that we're doing in the exposures and assigning different products or different devices that we can utilize for those different applications. So we learned through that process that no, there's no silver magic bullet that's going to cure this for us. And really, I think that's a misnomer that may be common or a misconception in the field, that people think, wow, I can use this one device and it's going to, you know, I can use it for everything, but that's not the case. So with that, I really encourage everybody to take a closer look, do a deeper dive and figure out what you do need for your different applications.
Great, thanks, Corey. I appreciate you going into that detail. I did see a question chatted in about about some resources that show the value of construction companies addressing fall protection by using prevention through design. In a couple of, I think it was the webinar that we did for the American Society of Safety Professionals last year, Adam talked about some tools that he has as far as when they look at some pre-construction planning and so forth, pre-con type stuff. And so I'd encourage you to shoot an email to Adam to follow up on that. I think he's got some really great resources to discuss that. And not only that, but he also has a couple nice photographs as far as some experiential exercises that they do from working on that. So just wanted to address that question real quick. Dan, I'm going to come back to you on an equipment item. So one question that came in relative to equipment was they were talking about a rope grab, and they're talking about the springs on it. So I think they're not necessarily just focusing on the springs, but just focusing on the mechanisms associated with using a rope grab or a fall arrestor that a lot of people call them. So is it strong enough so that if somebody grabs the rope or grabs the fall arrestor so that it won't slide down, and their concern is that it happens when the employee starts to fall, they start grabbing, and that fall arrestor might be something that they grab onto. Can you talk a little bit about the fall arrestor and some new requirements that are associated with the 0.15 standard, I believe it is?
Yeah, and this is a great question. And, you know, I think a really important part of understanding fall protection and particularly fall arrest equipment is having a mechanical or an intellectual curiosity. The best way to handle a rope grab is to never handle a rope grab. And if we look at the basic mechanics of most rope grab products, you're going to have a channel or a tube through which the rope is going to pass. And we're going to have some kind of a lever or cam, which is what's creating that fall arrest engagement. And the springs that put tension in that cam are there to facilitate the beginning of tension, but were they strong enough to actually create a locking engagement on the rope, you'd never be able to disengage and re-engage this device easily during the course of work. The best way to manage a rope grab if you're elevating is to actually elevate it by way of the ring or your lanyard attached to the ring on the grab and advance it from there without ever touching the rope grab itself. Vertical lifelines, whether they're used in a vertical or even a semi-vertical or sloping manner, should be counterweighted. So there's always tension in that line that will facilitate that easy ascent. And if I have a lanyard attachment, I can grab the lanyard and I can move that grab up the line without ever touching the grab. In the event I fall, even if I'm holding onto the lanyard, I'm going to engage the lever, which is going to create a firm locking engagement on the rope. And there's never that chance for that pulling down action, which can force the grab to slide downward. If I'm descending, the same thing is true. I want to lift the lever with my lanyard and encourage it to kind of move down the rope. And if it's counterweighted, it will have a better, smoother relationship either in that ascent or descent mode. But the most critical point I can convey is if you're handling a rope grab, the best way to handle it is to not handle it. You must handle it indirectly by way of managing your lanyard connection.
Dan, I appreciate you clarifying that. Sometimes when I'm showing that, I'll mention it's the deaf man's grip, right? As far as having it and essentially gripping onto it. And if the worker does go through the fall, that is. Now, some of the devices are obviously being built with, backup arresting mechanism and so forth. But Adam, I want to kind of deviate a little bit. I want to go over to you real quick because I think that brings up a great example as far as the experiential exercises that you put your workers through on job sites. So I was wondering if you could give us maybe a minute or two about that because, as Dan describes, how to use the product, if the workers aren't given a situation in which they can demonstrate that use, then how do you know that they have that skill? So Adam, could you spend a couple of minutes just talking about just the experiential exercises that you guys put your workers through on the job sites and how those are distributed throughout your organization? Adam?
Absolutely, Tom. So, when you talk about training, there's a couple different, ways to deliver training, but it's been proven over time that adults learn by experiential training. You take craft employees, any employees, you stick them in a room and give them 8 hours of a PowerPoint, maybe 15-20% of that's going to be absorbed. So for when it comes to fall protection, we do have a classroom portion, but where the real meat is that before anybody puts a harness on any of our job sites, they go through a experiential training or a fall protection simulator, which our employees have to prove to a trainer that they can safely navigate through the entire simulator using all the pieces of fall protection equipment that are provided on that site. And so that's beamers via Kuninga beam, that's a horizontal lifeline, that's a SRL that's mounted to a ladder and a scaffold, tying off on a scaffold. In the event that we're going to use rope grabs, it's a vertical rope grab, a beamer operation. So just kind of all the ancillary pieces of fall protection that we purchase for that site that are needed for that site. They have to prove it to us, and also it gives our employees a safe environment to make mistakes. And I think that's one of the most crucial parts about it is that employees have to make decisions about how they're going to tie off in the field, numerous decisions every day. And so we provide an environment before we put them in that scenario that says, you know, make your decisions here, and we'll coach you through the opportunities that exist in those decisions, and try to get them calibrated so that when they go out and play for real, like we like to say, that that they're successful every time.
Great, thanks, Adam. Appreciate that context. And again, I think that's a great tool that you make available for the folks out there in the field. So we're going to switch a little bit, and I am keeping an eye on the chat box. So if you have a question again that you want to jump in that relates to it, feel free to jump in with that question. I'll keep an eye on that, and we'll ask it in the moment if it's appropriate. But Corey, I want to come to you with this next question. It deals with the position of wearing a body belt for restraint on steep roofs. Now, when the person used steep roofs, I assume they're talking very specifically about the 4 and 12 slope. Everything below that is a lower flat roof. Everything above that is a steep roof. And I do want to note before Corey gives the item, there's a reason why OSHA doesn't allow a warning line system for a slope greater than 4 and 12. It's because you're going to have so much momentum that you're simply going to go through the warning line and possibly go off the edge. So, Corey, I wanted to pass that question to you as far as using a fall restraint system on a steep roof with that context. Corey?
Thank you, Tom. So in that situation, I would definitely recommend going to a full body harness, just because there's a likely potential that system may become a fall arrest system, and not truly a fall restraint. So I would plan that accordingly, just so you had that capacity in the system. And I think even from an end user, from a worker up there doing the work from a comfort standpoint, the full body harness is a much better option than the body belt. If something does go wrong, you're going to be glad you're wearing a harness and not a belt.
Great, thanks, Corey. So Dan, I want to build on that a little bit, and there was a question that came in about the minimum strength for a restraint anchor. So kind of thinking about it, not necessarily for a roof application like we were talking to Corey about, but just thinking about the overall items for the restraint anchor, because the person thinks that safety professionals tend to migrate towards arrest first versus planning for the fall versus trying to use restraint to not have there a fall. So can you go a little bit as far as talking about the anchorages needed for fall restraint?
Well, if we look at what the Z359 code suggests in Z359.2, which is our standard for managed fall protection programs, where restraint anchorages are concerned, it suggests that a minimum value of 1,000 pounds be achieved for a non-certified anchorage, or that a 2-to-1 safety factor is managed for those that are certified. And then in C359.6, there are different allowances for restraint anchorages based on whether or not they are temporary or permanent. But an interesting feature of Z359.6, which is our engineering standard for active fall protection systems, is that when it comes to permanent restraint anchorages, it recommends that they all be rated for fall arrest. And the reason for that is we always hope for the best but plan for the worst. And so despite the fact we have this lower allowance in terms of anchorage strength for restraint anchorages, I always recommend that people subscribe to those fall arrest numbers that we look to achieve of either 5,000 for uncertified anchorages, or managing our 2-to-1 safety factors when we have certification involved with qualified persons. Because if there's a miscalculation, if there's an opportunity for the user to select a different connecting element than is prescribed for that particular anchorage and fall hazard, then we can have a different outcome. And what was supposed to have been fall restraint may in fact become fall arrest. And it's always better to have, that higher margin of safety factored in.
Yeah, Dan, I talk to people, around the world with one of my volunteer jobs with the International Society for Fall Protection, and that's one of the fallacies that we often talk about when it comes to fall restraint, is that if it's misused, it can very easily be brought into a fall arrest situation. And so even though you could possibly use a body belt or possibly use a lower rated anchorage for lower strength anchorage for a restraint system, is that designing it for fall arrest and then maybe using a procedure for fall restraint is a great method. And just want to, looks like Dina has a question as far as body belts being illegal. Yes, Dina, just want to clarify that body belts are illegal to be used for fall arrest. I'm not sure if that was somehow misconstrued or something like that. So I just wanted to clarify that. And let me see, before we end that, we had a question that came in on suspension trauma from Ron. Appreciate you texting that in, Ron. Who wants to take the suspension trauma question as far as discussing the issues around that? Hey, Dan, since you're on the screen, why don't I start with you, and then I'll see if Adam or Corey wants to start or finish up. Dan?
Okay, and what was the specific question related to suspension trauma?
Sure, it was just discuss the issues around suspension trauma. So not a specific question. So okay. Dan, let's take a 30-minute topic and reduce it down to maybe a minute or two, the highlights, and then we'll see if Corey and Adam want to jump in to clarify anything.
You're asking the wrong guy. But I'm glad that question came up, because I've actually seen several articles on LinkedIn recently that have suggested basically that suspension trauma really isn't a significant concern. And, you know, the absence of hard data on suspension trauma doesn't necessarily mean to me that it isn't a problem. Anybody who's been suspended in a harness for any period of time knows that it's inherently uncomfortable. And in the event of a fall, assuming that I wasn't planning on falling, I'm probably going to be a little bit excited, perhaps a little bit concerned, quite possibly banged up or even injured moderately or even severely. And so the compounding factor of hanging in my harness after the fact, waiting for somebody to rescue me without necessarily understanding the details of who's coming for me, when they're coming, and how they're going to get me down, it's all compounded by the fact that I'm swinging in the breeze and extremely uncomfortable. If nothing else, it's going to be a very unpleasant experience. But if we factor in all the other things that are going on, that experience has the potential to be injurious. So it's best to prepare for these things and have some measures in place, such as the suspension trauma straps that are commonly available from virtually all manufacturers, a site-specific and hazard-specific rescue plan, and understanding that we have a dedicated rescue crew or persons who are responsive. And you know, all of that plays a part in reducing the potential effects of suspension trauma.
Great, appreciate you clarifying that, Dan. And just wanted to let you know that Ron did clarify. I saw that he was looking at as far as the termination of a proper assessment of a rescue plan that is not call 911. So Corey, maybe I'll dump that one over to you as far as, is a rescue plan calling 911? You know, obviously the answer is no, but can you kind of give that, because you have some background as an emergency responder, so you can provide a little bit more color commentary on that. Corey?
All right, thank you, Tom. So we definitely need to make sure we have a rescue plan, and the rescue plan is not simply calling 911. I would strongly advise you to take a look at different options that are available, whether you have man lifts on the job site, whether you need to potentially purchase a system. There's a lot of different systems on the market, everything from, you know, lanyard style, or I should say webbing ladders that you can deploy and drop down to a worker. Now they have to be conscious and able to, you know, grab onto that and climb back up, to other systems where you can potentially get to that worker, get them hooked up, and then either raise or lower them depending on the circumstances. So you really need to take a look at where you're working, what the access and egress looks like to that work location. Are you able to get there, help this person, or do you need to use another type of device? The other thing I definitely recommend is coordinating with the local emergency services. And so depending on where you're working, you know, is it a remote location with an all volunteer fire service? Are they equipped? Are they capable? Are they trained to come and assist in that rescue operation? Or are you more in a metro area where you have a paid career department that has the resources available to come and assist? So definitely you want to take a look at those aspects when you do your site-specific rescue planning. Reach out to those folks, have them come out to the site, do a walkthrough, do a meeting, and say, hey, here's where we're going to be working. We can foresee potentially this type of rescue. We're going to have people up there. What if something happens? Are you going to be able to help us out? Then walk through those scenarios. And then, like I said, take a look at what gear you may need to employ at the site and train the, you know, the forces on how to use that so that we become, or the site becomes, the first responders. Because, you know, in that first 15 minutes, it's critical to be able to get to somebody and get them down and get them to safety.
Great, thank you very much, Corey. Dan, I want to come back to you, and maybe Adam can add a little color commentary to this also. But there was a question I chatted in. I appreciate you, Jessica, for making sure I saw both areas where not only the chats but also the Q&A. Dan, there was a question that was chatted in, is there or will there be a standard identification on SRLs that will identify the minimum anchor height from the wearer's feet? Thinking about obviously the standard that's still under evaluation, so it hasn't been published yet. But can you comment about that as far as how the new Z359.14 is addressing the anchorage height from the users from the wearer's feet? Dan?
Yeah, and it's a great question, and it's obviously a goal of ours to make these products not only more robust and to have better factors of safety, but to make them easier to understand and easier to utilize. And the standard is presently in process with the Z359 committee, and hopefully will be published a little bit later on this year. We're changing the classification system. And so we're going to have devices under two classes, class 1 and 2. Class 1 devices are those that are required to be attached at or above the dorsal D-ring level or to overhead anchorages. Class 2 devices are those that have been tested to be able to withstand a fall from a lower anchorage elevation with the possible exposure to some kind of structural edge. And again, not a magic wand, we can wave at all of our problems, but we're trying to distinguish between SRLs that are intended to be used in overhead fall arrest and those that are designed to withstand more extremes of fall arrest. But I want to be clear that the class 2 variety that is described in the new standard is not necessarily impervious to all variables. So it's still very, very important to eliminate as many of those variables as possible to ensure the safest imaginable outcome. But yes, everything is going to be based upon a classification which is related to anchorage elevation.
Great, thanks, Dan. We do have a couple of questions that are going into more of the mobile lift side. So if everyone's familiar, the newer term that manufacturers are using now is mobile elevating work platforms, so the term MUPs that are under the new ANSI 892.20 standards. So that's not only for scissor lifts, but also articulating boom lifts. So I want to get to that in a second here, but I do have a question came in from Jane. Is there anything in the current standard or the future state where you start adding some thou shouts for engineers, a la the CDM type language? And what Jane is referring to is the CDM regulation that's in the UK for construction design management, in which, in essence, from project inception to project decommissioning, safety has to be considered by the owner. So Jane, great question. And unfortunately, there's not a lot that's been done on that yet. It's something that I think it needs to be more of a grassroots level, but it's obviously a much more effective way to address the hazards than doing that. But let me get back to these scissor lifts questions. So Corey, first question is, do I need additional fall protection for a scissor lift? When I read OSHA, it says, the guardrail, provides all the, the protection that I need, but then manufacturers have the anchorage in the lifts. Can you give a little explanation on that?
Sure. So remember that the OSHA standards are what? They're the minimum standards, right? And so even though OSHA says that you may not need to tie off in that lift, it is recommended. It's best practice to do so. And looking at different types of systems to do restraint so that the people working in the lift cannot climb up on the rails, cannot get out of the lift, and so on and so forth to potentially fall, would be the best practice to employ in that situation.
Great, thanks, Corey. So Dan, I'll come to you from more of the aerial, the articulating or boom style lift. What kind of fall protection do I need in addition to the railing when using our articulating boom lift? Can you take us through the whole, traveling with the lift versus the, working out of the lift and what the differences in the fall protection system are in that, Dan?
Well, anybody who's been, on a Zoom call in the last year or so, or been sitting in on a webinar such as this one, has probably spent a little bit of time on YouTube. And if you look at some of those videos of, aerial lifts being used, perhaps erroneously, we've all seen examples of what that ejection looks like while traveling. So it's a very real, clear and present danger to the user. So we recommend, multiple forms of fall protection for the articulating boom lifts. Number one, when traveling, restraint is critical. We want to keep the user inside the basket should they hit a curb or a pothole or some other obstruction that's going to create that potential catapulting effect. So, a 2 or 3 point restraint system tied into the hips and the anchor points underneath the control panel are going to be exceptionally effective. When we get to an elevated working location, then transitioning to fall arrest is a very smart strategy. It's going to allow us access to our work platform at height and whatever our work is. And the event that we overextend ourselves and do fall out of the basket, we then have that fall arrest device working for us. But very, very important that we select a fall arrest device, whether it be a lanyard or a personal SRL, that has an energy management feature at the point of attachment to the harness, not at the point of attachment to the anchorage. Because if I go over the rail, I don't want to isolate my energy absorber or my energy management feature inside of the basket. So most of your traditional personal SRLs aren't going to be adequate for fall arrest inside of a basket, even in that elevated work location. So we have to choose our tools very, very carefully. But again, restraint for travel, fall arrest for working at height.
Dan, we had a question that just came in that addressed this. So Stacy asked, is it reasonable to expect, and Adam, I'd love your input on this too, because I've seen a video of you using it. Is it reasonable to expect the worker to switch back and forth between those systems so that when they're traveling to the location, they're locked in with the restraint system that they're talking about, but then once they start working, you would expect them to switch to the arrest. Dan, can you start on that? And then Adam, I'll come to you, and then Corey, I'll see if you want to add in anything also. Dan, start with you.
It's a little bit more difficult and it's a little bit more complicated from a training and management perspective, but it's reasonable in that it's going to give us the best outcome. We have different tools for different jobs, and we all know that generally speaking, if you try and drive a screw with a hammer, you're going to get a pretty poor result. So it's helpful to have the hammer and the screwdriver in our tool bag. And by the same token, we have the restraint lanyard and the fall arrest lanyard in our tool bag too, because they have different advantages over one another depending upon our circumstances. So I think that in this particular circumstance, because of what we know about fall arrest devices, whether they be lanyards or retractables, they're just not sufficient when traveling to keep the user in the basket. And we've had too many high profile examples of how that doesn't work and why it doesn't work.
Great point, Dan. And just to amplify something, I think one thing we've often talked about, especially when it comes to lifts and the different solutions, the choice of the solution is as important as, the implementation of the solution is as important as the choice of the solution. If you can't implement it, and that gets back to the, one of the early discussion points, that's where it comes the procedures, the supervision, and the training that we're talking about. That's why these items are so critical, because if you have your workers do one item, but they're, require them to do one thing, but then they're doing something else, in some cases that can be almost as bad as not having any protection at all. Adam, do you want to jump in and add anything relative to the dual systems? Because I know that's something that you have that you use with your workers. Adam?
Absolutely. So, I like to think of things as, what would happen if we had a catastrophic event, right? And in this case, we're talking about a catapulting event that results in a fatality. So if we had that event happen, then how would we operate after that? And the answer is you would use a restraint lanyard for traveling, and then you would use a fall arrest method for, elevated work. So I would just say it's absolutely acceptable to ask your employees to do this. A little bit of a pro tip. When we first implemented this, I don't know, 5-6 years ago, we noticed that the devices that we're using to sort of hold our employees at the controls were disappearing from the lifts, and so we locked one side with a keyed lock into the lift, and then they stop disappearing because they make excellent lunchbox handles and straps. So a little bit of a pro tip there on that one.
Adam, I want to follow up on that real quick, because we had an item come in, and so it said, this information is very good information, thank you, but how do we better inform the workers in the field? And importantly, the supervisors, competent, qualified persons, that direct and design their work. There's that gap there. So Adam, what suggestions would you go maybe beyond the pro tip as far as making it better for them? I know you have videos. I know you have other things to support that. Adam, anything else you want to add into that?
Absolutely. So, we do various kinds of training throughout this, but the Restraint Lanyard is built into our aerial work platform training, and it is also we do a couple times a year. We'll do like where we have a dummy and we'll simulate a catapulting event. And typically, when everybody sees that, it doesn't matter if you operate an aerial work platform or not. When you visually see that dummy ejected from that basket, we don't have any issues with, when we first started this 5-6 years ago, occasionally we'd see people operating without the restraint lanyard holding them to the device. We don't have that problem anymore. Everybody really gets it that this is a life-saving type endeavor, and the key to saving people's lives in this instance is to keep them in that basket. Now, I will also tell you that if you have a catapulting event and you're locked into the control box, you're probably going to have some broken ribs. It's going to hurt, but you're not going to die. And that's the difference, and that's why we use them.
Great, thanks, Adam. Appreciate that context. So Dan, we have a question came in. I appreciate all the questions that come in. And again, if we can't get to your question, feel free to email us. That's why we included our email addresses. And if anybody, just a plug for the part one that Jessica talked about, we do have a couple of videos for leading edge falls and some swing falls in that previous presentation, if you want to take a look at that. And Jessica just informed me we can't go past the top of the hour, so we're going to try to keep on going as long as we can because some great questions are coming in. So Dan, the question that I'm going to give to you, and then I'm going to address another question before I come to you. Dan, the question that came in is, are boom lifts strong enough and stable enough to support fall arrest? That's the question I'll come to you in a moment with, Dan. But before that, there was a question from Nick where it talks about in a particular situation, sorry, my screen changed, in a particular situation to place a worker after they were involved in a fall, so the worker goes through a fall, they're suspended while waiting for emergency services to arrive. Some people have said not to lay down or place them in the W position. Nick, what I'll say about that is there's a lot of discussions out there. That's where you have to have the emergency services that respond. You need to make sure that you give them a full briefing as far as how long that worker was exposed, whether or not there was any movement, and so forth. That's a lot of, there's a lot of discussion about that, but that's something that you really have to put into the emergency responders that come on site and let them make the site-specific decisions because, we're not medical professionals. Well, Corey, you're emergency responder, so I'll come to you in a second, but that's something that you really have to leave to the medical professionals that are responding. Just make sure you give them great quality information that we go into that. Corey, anything that you want to add on to that before I go to Dan for the aerial lift fall arrest question? Corey?
No, nothing to add with that, Tom. I think you summarized it very well.
Okay, great. Dan, so we'll go back to you for the aerial lift. I'll try to summarize because it's not on my screen anymore, but what about using that aerial lift for a fall arrest anchorage? Does it have the strength? Does it have the stability for that? Dan Henn?
Yes, modern aerial lifts are rated for that, and the ISO standard for these lifts actually requires a drop test that's more severe than we typically do in the ANSI Z359 standards. But my guidance is if there is a manufactured anchorage point in your basket, right, that is clearly an OEM part of the basket, then go ahead and trust that that's going to work if you don't have other documentation in place. And what I can tell you about, modern fall arrest equipment, when it's uninhibited and selected correctly, is going to limit the arrest forces to an extent such that on a flexible anchorage, such as that basket, that the risk to the anchorage is far less than the risk to you when you make the choice to tie off. So always best in the absence of other information to tie off anyway and err on the side of caution.
Thank you very much, Dan. Let me see my next question that I want to go to. So let's get into some other items related to anchorages. And Dan, I'm going to stick with you on this one. Dan, this person is talking about butterfly or flat tie-down anchorage connectors. So the device that they had purchased from an equipment manufacturer and tying it down to wood or corrugated steel roofs. Why won't a butterfly tie-down for wood roofs not work on corrugated roofs per ANSI? So maybe you can clarify a little bit as far as how a manufacturer or qualifies their piece of equipment per ANSI, what they're not doing when they do the qualification, and then how they apply that out in the field. And I always love your story about when you were overseas and they were testing the anchorage connector. So if you could work that into it, that would be wonderful. Dan, back to you.
Oh, wow. Yeah, that's a hell of a thing. You know, there's a lot of variety when it comes to anchorage connectors, folks. And the type that Tom is describing here is prevailingly referred to often as a butterfly or a hinged roof anchor. And it's a very simple, reusable device, basically two steel plates utilizing a D-ring as a hinge pin, and it adapts reasonably well to a peaked roof or a flat surface. Most manufacturers will present these with alternative sets of fastener holes. One set for threaded fasteners or screws, lag bolts, and another set for nails. Now, typically, again, these are intended primarily for use on wood roofs. And generally speaking, if we're going into a residential roof, we're hoping that you're going to take that device and affix it through the sheathing and into a truss. We want to get a hold of something structural. And when we do that, we're hoping that based on the condition of the roof, that by capturing two independent structures, both the sheathing and the truss, that we have enough of a connection to the anchorage substrate that we're going to have a successful anchorage connector during a fall arrest. When we attempt to take that and adapt it to a piece of corrugated sheet metal, we can choose our fasteners to mate to the sheet metal substrate, but the corrugation of that sheet metal only allows so many connections to take place. So for example, if on each plate I have, let's say, 6, 8, or 10 screw holes, I'm only able to hit half of them based upon the, valleys and troughs, or peaks and troughs, then I'm not really getting a good, strong capture on that corrugated substrate. And I may not be getting enough shear strength out of the fasteners to successfully arrest a fall. So really, really important that we match the anchorage connector to the anchorage structure or substrate. And if we're using an anchorage that depends upon fasteners to create engagement, then we need to make sure that we're using the correct substrate, the correct fastener, the correct number of fasteners, and we've satisfied all of the instructional requirements to ensure that we've got a solid bond. Because generally speaking, your anchorage connectors that rely on fastener relationships are probably going to be the ones that are most vulnerable to misuse, and not necessarily through deliberation, but just on the basis of not having the experience or the mechanical understanding to judge what is a good anchorage connection versus what is not.
Great, thanks, Dan. And I'm gonna go on to Corey and Adam in a second here, talking about using a 5,000-pound chain in lieu of an anchorage connector product. But two quick items that I wanted to clarify. Samantha, you texted in a question. I really didn't quite understand it. So if you're still on the line, if you could clarify what that question is, we'll try to circle back to that. And then also Paula, I appreciate your great clarification when it comes to the studies, when it comes to suspension intolerance, as far as how there's a lot of discussion and so forth. That's why I recommend that we put it in the hands of the medical professionals that are arriving on site, make sure that we get them great information and make sure that they're able to transition the employee in a safe way. So let me circle back to equipment. So we talked about the butterfly anchors, and Dan went into some great detail as far as how they get fastened down, and there's the strength of the anchorage connector, the fasteners, and then the anchorage itself. But Corey, I want to talk about a 5,000-pound chain. It's very often where we see, especially in the construction industry, where people maybe fabricate their own anchorage connectors. So they might take what they consider to be a 5,000-pound chain, and they use that as an anchorage connector in lieu of a piece of fall protection equipment. Can you talk to that real briefly as far as material handling equipment for fall protection and fall protection equipment for material handling?
Absolutely. So those are two totally separate animals. So anything that's going to be used for rigging, for lifting purposes, for tie down purposes, like chain that's going to be used for trucking operations, it's designed, it's designated to be used for that purpose, for that application only. On the converse to that, anything that we utilize for fall protection has to be designed, rated, manufactured, so on and so forth, tested to be a fall protection device. So that's been a common misnomer over the years, and I saw it many years ago where in the steel erection process, you would have people that would basically just take a regular, 3/8 inch wire rope choker and use that as an anchor device just to wrap it around a beam, tie off to that, and keep going. We've learned and we've come a long way over the years, so that's no longer an approved type device, right? So just be mindful of that. Anything that you're using for lifting, for rigging, it's for that purpose, not for fall protection.
Thank you very much, Corey. Adam, you want to jump in on that and clarify anything as far as how Zachary addresses, the often, confusing differences between material handling and fall protection equipment?
I just have one thing to add. Corey did a fantastic job of addressing that, but in the event that somebody happens to use a piece of fall protection for rigging or tie down or any other application, it's quintessential that that piece of fall protection equipment gets taken out of service immediately. You don't know what's happened to that as far as stretch or anything else, and so you just want to discard it and move forward.
Great, thank you very much. Appreciate that, Adam. Looks like there's another question that came from Corey. So not Corey who we have on the panelist, but another Corey that asked a question. Is any engineering being done on guardrails on a slope roof? I realize different slope, different friction, lack of distance of a slide and weight of a person. Just seeing guardrails set up on a steep roof and they're only engineered for 200 pounds. I believe his name is Tom Bobick from NIOSH, has done some analysis on that. So I'm not sure if Jessica has any links to that or something like that, but Jessica's been doing a great job as far as just, putting a lot of links into the Q&A box. So please, Jessica, if you're able to find anything on that, I can't remember what they published, but I believe that Tom, he works down with Hung Wei, who's very often at our ANSI Z359 meetings, and also Tony down there in the West Virginia office of NIOSH that in the Morgantown area that have some research, and they actually have some full-scale items that are there. So one other question that came in, Dan, is that somebody asked if you could clarify why we have the 130-pound limit when it comes to the user weight. So if people aren't familiar, in our Z359 standards, we talk about a lower weight of 130 pounds and an upper weight of 310 pounds, and that includes tools and clothing. And I remember, at one point somebody had asked, well, if somebody's under 130 pounds, maybe they could just put a heavy vest on that you see people when they're working out. That's not the right approach, definitely not the right approach, but there is equipment for 130, for workers under 130 pounds. Dan, can you give a little background from a manufacturer's perspective as far as why we want to be mindful of that 130 limit and especially employees less than 130 pounds? Dan?
This is going to seem shocking, and I don't want to be provocative, but sit down for just a minute, because we're still learning things about how this equipment works and how it behaves. And one of the reasons we're still learning is that the workplace and the workforce are both changing. And as these technologies have been evolved and we've developed new solutions, we also see new behaviors taking place. And so as a result, when these regulations were put together in Title 29, back in the 90s, and the early ANSI Z359.1 standard was put together, it was all based upon kind of the universe of fall protection solutions that was available at the time, the behaviors of the workforce, and the makeup of the workforce. Well, a lot has changed in the last 30 years, and we're working on kind of catching up to that. Now, when we look at the lighter weight worker, one of the compounding factors is that when we have a deceleration device, something that's designed to take the energy out of a system, we have to have a certain amount of input force to begin a deployment in order to execute that deceleration. And so we have an extreme lightweight worker, and let's say we have an 80 or 85 pound person who's a fully grown adult, in the workforce working at height, but is engaged, in active fall arrest, how far do we have to drop them before they're generating enough kinetic energy to appropriately deploy a deceleration device and allow us to manage that energy? If we attach them to a common conventional deceleration device, a typical energy absorber, they might not generate enough force to actually deploy it, in which case they're going to be subjected to an injurious level of G forces or arrest forces. So we really are in a position where, with the evolution of the American workforce, or the international workforce for that matter, we're going to have to take a look at how do we protect everybody. And what it's going to mean is we're going to have additional tools in our toolbox to deal with those circumstances. So if we go back to that question we had earlier about, is it reasonable to have a restraint and an arrest option in the same application and the same process? The answer is yes, and not only is it reasonable, it's necessary, but we have the same compounding factor going on here, wherein if we look at protecting all of our workers, we're going to have different options available to us to ensure that we're meeting the needs of not just the heavier weight the commercial demand is at right now, but also this whole new category of persons coming in that's becoming a larger part of our workforce, which is that lighter weight individual.
Thanks for that, Dan. And just as a side note, if you're able to attend any of our Z359 meetings in the near future, Sean Smith from the U.S. Navy, he's the interim chair for Z359.7. He cares a lot about the lower weight worker, because when you look at across the community in the U.S. Navy, a lot of the maintainers and so forth, they do have a significant number that are less than that 130. And so he's actually done some research. So if you're interested in some of that research, please let us know. We can put you in touch with Sean. Also, thank you to Jessica. She put in some links to Tom's research at NIOSH. I appreciate on that. Corey and Adam. Adam, I'll start with you in this case. We're talking about competent person and a fall protection trainer. What's required to be considered a competent person or a fall protection trainer? Can you go into a little detail as far as what you guys do relative to that, and maybe give a little, maybe an example or two? And Corey, I'll hand it off to you to maybe expand on some areas. Adam, we'll start with you first.
Yes, it'll be a competent person or a trainer. You have to go through a 24-hour, 3-day class. You have to prove that you understand all the intricacies of, identifying anchorages, selecting a fall protection solution based on the situation, et cetera. And then also prove through an interview process that you understand how, not only can you pass a test and sit through a class, but you can articulate that you understand how fall protection equipment works, and what the specific solutions are for the various scenarios that exist. So that's kind of that's what we do to identify competent persons in our job sites.
Thanks, Adam. And I don't want to steal any of Corey's thunder, but I want to mention, just because Adam referenced it, but that 24-hour threshold that Adam talked about, that's a requirement. I think it's Chapter 21 of the U.S. Army Corps of Engineers EM 385-1-1 manual. And so when you're on a U.S. Army Corps job site and the EM 385 manual is being used, anybody that's exposed to a fall hazard situation has to have a competent person that has those 24 hours of training. So I just wanted to highlight that and amplify that as far as what Adam shared. Corey, I didn't want to steal any of your thunder, but I just want to make sure we caught that. Corey, on to you with anything you want to clarify or amplify as far as what Adam shared. Corey?
No, Adam, that was the great summary, and I think that's definitely the mark everybody should shoot for in terms of getting personnel trained in order to go out and teach and be the competent person. But Tom, I don't know if you want to kind of transition and maybe just go back to maybe OSHA definition and ANSI definition, of those terms, just to clarify a few things. So just remember, everybody, that OSHA's definition is a little scaled back. We always say OSHA's the minimum, right? So OSHA's definition of competent is somebody that's capable of recognizing existing hazards in the workplace and then having that authority to go ahead and make corrections for those hazards. So in terms of fall protection, it's basically, identifying those fall hazards and being able to correct them, but not so much diving into the ins and outs of what devices or what types of fall protection may be required. that's more so, I think, transitioned and covered more under the qualified person definition, which is somebody through education, training, and experience, usually a recognized degree or something like that, can make those determinations, do the size up, and then determine what different devices or systems may be required. So Tom, with that, I'll kick it back over to you for any clarification.
No, we're good on that. Thank you, Corey. Did have another question come in, again, from the Corey in the audience, not from the Corey here, but Corey was asking a scissor lift. Let me see. Okay, they use a scissor lift like an elevator for multiple people on roofs where it's greater than 40 feet. They're putting people in the lift, then they raise it up, then they step off the lift. As long as the gap is less than 2 inches onto the flat roof, they have guardrails at the edge that's almost touching the lift with a very, very small gap there. And then the question is, and then they place a board across the potential gap. And Corey's question is, do you feel this system is that can be adopted as acceptable? So I'll see if any of the panelists want to answer after I jump in there. So one thing that I want to emphasize, Corey, again, Corey in the audience, not Corey as a panelist, is that that all the manufacturers have requirements for vacating and entering an elevated aerial lift. This is something very, very critical that you need to be conscious of, is that the manufacturer will give you that procedure for vacating or entering the elevated lift. And so what I would recommend is that Corey in the audience, go ahead and reach out to that equipment manufacturer, if it's JLG or a Genie, or maybe reach out to Sunbelt if that's who you're renting it from, or United Rentals or whoever, and check with them as far as what that procedure or process is. They will give you a written document. Now, you can't just necessarily reach out to anybody. You might need to make sure you get to the right person, but that's a procedure that I've often seen in the industry as far as using that. Any of the panelists want to jump in and clarify anything like that before we move on to our next question?
I'll hop in for a second. So I think understanding that there is certain times when you need to enter and exit any type of man lift or aerial work platform, but I think that's something that should be managed by exception. We like for us at Zachary, you have to get a permit signed by a project manager and the safety manager saying that, hey, we've tried every other means to get an employee to where we need to get them, and this is the only way to do it. And so that transition period in and out of aerial lift is crucial, as Tom mentioned. There's a lot of risk associated with it, so I would not recommend it as a general practice. I would say that it's something that should be managed by exception.
Thank you very much, Adam. Appreciate that. Corey, I'm going to come back to you, and Adam, of course, you can jump in on this one. This is dealing with a site-specific situation. Corey, is a question that came in, is explaining the testing criteria for guardrails. And maybe it's, testing criteria might be the wrong term. Maybe you can use as far as how do you make sure that your guardrails that are nailed are properly strong enough. And so the question states, OSHA states 200 pounds of force applied downward and outward. And I always say in our training classes, don't test them outward, in case something, bad happens on that.
Breaks.
Exactly. But can you talk about how in the field do you judge to make sure that the connections between the post and the rail are strong enough, not only for the top rail, but also the mid rail and any other connections? What do you do? Because you've talked about how you have some engineers, designing your fault protection systems. Mm-hmm. What do you do for guardrail situations? So I'll start with Corey, and then I'll come on over to Adam if you want to clarify anything. Corey?
No, thank you, Tom. So we have some standard details depending on the work that we're doing and where we're going to place a guardrail, whether it's going to be on a concrete slab or whether it's going to be as part of a form system, platform system, whatever it may be. So we basically install those guardrails to those specifications. They are engineered. So to them, I was looking in the chat box, and so to the question about, how do you know that you're using the right nail, right? And whenever you drill that hole to drive the nail into, are you going to drive 2 in or just 1? What's the diameter of that hole? All those things need to be considered, from an engineering standpoint, to ensure that system, once it's installed, is going to, in fact, work, right? In case somebody does fall against it. The other part of the question, I think, is They were asking about how do you know, or how can you just give it that test in the field? And Tom, correct me if I'm wrong, but I believe that the OSHA requirement is, that guardrail shall not move more than 3 inches when that 200-pound force is applied in that manner, correct? Yeah.
Mm-hmm. Yeah. Yep. Yeah, it can't deflect 42 inches plus or minus 3 inches, but can't deflect underneath that 39-inch mark. Adam, you want to clarify anything? Because obviously with the variety of projects that Zachary's involved with, you get into a lot of circumstances where I'm sure you're having to make some protection guardrail up, on the job site. Adam?
Yeah, so one of the things that I think is important is that utilize your QA QC team. They're there to check obviously quality of your finished product and what you're putting together for your customer, etc. Pumps, motors, and so on. But get them involved in your engineered fall protection systems and your guardrail systems. Let them. This is what they do for a living, right? Dive into specs and make sure that it's installed correctly and do the proper appropriate test. I think maybe too often it's in the safety department we might think, well, like if it's fall protection, then it's got to be safety. Use the other resources around you to really help kind of your overall project be successful.
And Adam, just building on that, if say it's a smaller organization that maybe doesn't have all the resources, they can build mock-ups. They can build mock-ups on the ground and test them and use that as documentation, or maybe if they have an engineer that does certain research, or not research, but analysis for them, they can use them to do some of the analysis, especially for guardrail type situations and so forth. Is that a good approach?
100%.
Awesome. Okay. We're wrapping up. We got about 12 minutes left. I want to make sure that we get into this question because I think it's going to get into where we see fall protection going on in the future. So Dan, I want to start with you on this. Is there any technology on the horizon that will improve fall protection for workers at height? So Dan, that's a broad question. We only got 12 minutes left. I still have Corey and Adam that could give an answer. So can you give us maybe 3 or 4 minutes as far as putting in the your crystal ball as far as what do you see in the future for fall protection? Dan?
Well, I mean, the short answer is, of course there is. And it's going to be great to steer with the catcher's mitt on and wait for that to come across the plate. Where is it happening? It's happening in retractable technologies. We're seeing a lot of system technologies in terms of whether it be horizontal lifelines, rigid rails, mobile anchorages. I'm very excited about a lot of things that are happening there. But I think more importantly than that, if we really want to look at how are we going to see better outcomes in the future, let's stop relying on the technology to save us, and let's get back to some good, solid fundamentals, right? Like the hierarchy of controls that was mentioned earlier in this presentation. If we can engineer out the fall hazards, and we really don't have any need for fall protection technology at all. So why not start there? If we can utilize, active restraint systems instead of fall arrest systems, and we, eliminate that possibility of a fall, and that's a pretty analog type of technology, why not just start there if we can? As Adam said earlier, these leading edge devices, whether they be SRLs or conventional energy absorbing lanyards, are the hottest thing going in fall protection right now, commercially speaking. But they also introduce an increased level of risk because we have this great clearance required, we have the condition of the substrate, and we have the potential for injury. As Adam was talking about, the MUP restraint system, just because it works doesn't mean you're not going to get hurt. Same thing is true of fall arrest equipment. So again, I'll go back to say that, the best thing we can do from a fall arrest standpoint is elevate that anchorage, just like Adam said. So why are we in such a rush to tie off at the foot level when we have alternatives at our disposal? So I would say that, yes, there's a lot of technology and new engineering going on, a lot of new products being developed, and, all those will be revealed in time. But if we really want to see the best possible outcomes, we need to get back to, playing small ball here, work that hierarchy of controls, elevate those anchorages, and look for opportunities to reduce the level of risk that we're introducing to the individual worker's experience. And the more that we become reliant on technology to solve that problem, the more risk we're introducing. So I'm going to point back to that hierarchy. and that anchorage elevation, just some good solid fundamentals of doing those things that we know work, and seeing what technology brings us in the future.
Folks, I just want to emphasize that answer because that answer is coming from an equipment manufacturer. So if you have an equipment manufacturer saying use equipment less because it's more the cure versus the prevention mindset, that I just want to emphasize that. And that's where I'm hoping one of the lessons learned we take from situations like COVID is that the more we can do to prevent the situation from occurring versus trying to cure it once it does occur, it's the best situation. You can think about from your health standpoint, from a legal standpoint, from a pharmaceutical standpoint. There's plenty of examples in our life that once we get to curing the situation, and that's example of curing is fall arrest, then there's a lot of outcomes that will happen naturally because we've gone so far down the road. So Corey, you're next. What kind of technology do you see on the horizon, or what do you see as approaches that are going to take your fall protection programs to the next level in the coming years? Corey?
All right, thank you, Tom. So before I get to that, I wanted to make a quick comment back to that 2x4 guardrail system question. And I just wanted to say this, and it's going to sound very basic, but just make sure whenever you're constructing those that you have your vertical upright members, that you're placing those 2x4s on the inside of those versus the outside, right? Again, go back to your details, work with the engineering staff to determine what's going to be best, but generally that's a best practice. So I just wanted to say that. And then, to the future of fall protection, wow, how far in the future do you want me to go? Like, you talking about like wearing like anti-gravitational suits and things like that, or, you never know where it's going to go. But I agree wholeheartedly with Dan's comments in terms of trying to take the step back, look at how can we engineer out the fall hazard, and then when we do have to put somebody at risk in those situations, how can we best protect them, knowing that fall arrest is that last resort. So let's go through and exhaust every possible option before we put somebody in that situation.
So Corey, who drives that in your organization? Who drives that? Is that something you drive, or is that something that others drive?
I do.
Help me in that.
I do, but fortunately, our senior management team is very behind that in looking at, I'll say very creative ways to do work and minimize that exposure. And then knowing that when we do have people exposed, but just like Dan said, back to let's play small ball. What's going to be the best device? What's the best anchor point? Can we elevate it, visualize the outcomes, and make sure that it's going to be the best situation we can?
Great. Thanks, Corey. Adam, your thoughts as far as technology or where the future of fall protection goes. What would you like to add to what Corey and Dan have already shared?
I think one of the things I'm most excited about is that on some of our newer projects, we're starting to engineer in fall protection systems into the structures. And so essentially, once you get your steel up, your rigid rail, right, fall protection kind of grid system will already be in place. And so as you put down grading, as you continue to hang pipe and put vessels and other things into that structure, there's an availability for somebody to be anchored above their D-ring, and as they walk around that structure wherever they need to go, their anchorage point just follows them. And I think that's kind of where the immediate future of fall protection is I can't talk enough about how excited I am about the potential of the rigid rail system. And I know we've had it for a long time, right? Airplane hangars, maintenance hangars, and things like that is where a lot of but really kind of integrating that into the engineering for construction, into the overall build, I think is going to make a tremendous difference in the world of fall protection, especially as it relates to construction moving into the future.
Great, thanks, Adam. So if I could summarize, maybe I could say that you're looking to work smarter, not harder, and take into account what the equipment manufacturers maybe give you from a robustness standpoint, making the equipment more robust so that in that accidental misuse scenario, the equipment or the worker's protected, but we don't have that issue as far as, where their equipment could possibly sever and cause a catastrophic failure. Is that a good way to maybe restate what your thoughts are on that?
Absolutely, and I think additionally you have a real value proposition to your customer who's going to ultimately take over this plant or this building or whatever you're building for them, is that their fall protection system will be in place. You'll leave it there, so
Right.
they'll have it as well for their maintenance activities. So I just think it's a win-win all the way around.
Great. Thanks. Well, we're getting close to the end, and so I want to just say thank you, gentlemen, for all your time this afternoon and all your expertise that you were able to share with our audience. We do have Jessica put back up the contact information if you'd like to shoot us any email and have us clarify anything. But thank you very much for we had nearly probably 3/4 to 80% of the audience still stay on for the entire hour and a half. So thank you very much again for taking time out of your day to join us here to talk fall protection. Obviously, hopefully it's something that you see that all the folks here have a great passion for it, and so hopefully we've been able to make the world a better place, improve safety and reduce risk for workers at heights for this. And I wanted to say a final thank you to Jessica and all the folks at CPWR for all the work that they're doing. Again, keep in mind they have a lot of resources relative to the fall protection stand down that's coming up May 3rd through the 7th. Hopefully you can take some of the information here and share that during one of your fall protection stand down events. But thank you again for our panelists. Thank you again, Jessica. Thank you again, CPWR, for hosting this webinar. And Jessica, I'll pass it to you for any final words.
Yeah, thank you, Tom. Thank you all for such a great presentation. We got the suggestion that this should be a quarterly event going forward. So really, really great information, guys. And I know there are always more questions. So everyone has our presenters' emails, but you can feel free to contact me at CPWR as well. And once again, we will be sending out a recording of the event in a follow-up email. I'll also include a recording of the last year's event in that email as well. So yeah, thank you everyone for joining, and thank you for taking the time, especially the extra time out of your schedules today, to our panelists.
Thanks, everyone. Stay safe, stay healthy.
Thank you very much. Take care.
Bye-bye.
Thank you very much. Pleasure.